Hello, my dear students. How are you? I hope all of you fine. Today I am going to take arithmetic progression. Can you see this picture? Yes. In a nature, in our daily life, we can see many things follow a certain pattern. What is a pattern? Pattern is nothing but, can you see this picture? The first one is sunflower. The petals of the sunflowers. How these petals are arranged in an order. That is why this flower is looks so beautiful. The same thing, the honeycomb is also arranged in an order. That is why it looks so beautiful. As well as the pineapple is also looks beautiful because these are all arranged in an order, particular order. Pattern means is nothing but a particular order. Before you are going to study about the arithmetic progression, first we have to understand what is a sequence. A sequence is nothing but a collection of numbers in a definite order according to some definite rules is called as a sequence. I will give one example. Can you see this example? First one, 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7. What kind of a set this one? What kind of a sequence? That is a natural number set. 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7. It's a natural number set. Sir, you told sequence is nothing but a collection of numbers. Okay, 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 is a collection of numbers arranged in order as well as. Okay, next, what is the definite rules follows here, sir, in this example? Yes, the rules is take the first number 1. Okay, what is the second number? 2. How did you get the second number? Add 1 to the previous number, first number, we will get the second number. The same as it is, add 1 to the second number, we will get the third number. So on, add 1 to the previous number, we will get the next number. The process is continuous. This is the rules is followed in this example. Can you see the, let me take another example. Can you see the second example? 1 comma 2 comma 4 comma 7 comma 11 comma 16 comma 22. What kind of rules is applied here? Yes, I will tell you. Add 1 to the first number, we will get the second number 2. Add second number to the second number 2 plus 2, we will get the third number. Add 4 number to the fourth number, we will get the fifth number. The process continues. Okay, take another example. Can you see the third one? 1 comma 4 comma 5 9 comma 16. What kind of, anyone tell me what kind of rules is applied here? Yes, square in the first number 1, second number, the natural number set, square in the second number 4, third number 3 is 9, fourth number 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64. The process is continued. This is the rules. We can write it so on. Okay, it will not end. Okay, the fourth one, same as it is, squaring the natural, cubing the natural numbers. The first one, 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216. Okay, likewise it's so on. This is called as a sequence, a collection of numbers arranged in an order, an orderly arrangement with a definite rules. This is called as a sequence. Then next we will move on to each number of the sequence is called a term of the sequence. Each number of the sequence is called as a term of the sequence. I will tell you later. Okay, the sequence is called finite or infinite according as the number of terms in it. The sequence is divided into two types. One is finite sequence, another one is infinite sequence. Finite means we are number is there. For example, in a set, natural number set, that is 1 comma 2 comma 3 comma 4, it will end, there is no etc. Okay, how many numbers are there? Only 4 numbers, 1 comma 2 comma 3 comma 4. This is called as a finite set. The counting number of a sequence is called as a finite sequence. Then what is infinite sequence? As you know that the counting number of a sequence is called as a finite sequence. What is the uncountable number of sequence? It is called as a infinite sequence. Okay, so take the same example, that is 1 comma 2 comma 3 comma 4 etc. It will not end, we can write it so on. Okay, that is called as a infinite sequence. Okay, now we will move on to the definition of arithmetic progression. Definition of arithmetic progression. What is arithmetic progression? Arithmetic progression is nothing but it is also a sequence. It is also a sequence. Sequence means it is an orderly arrangement of numbers with a definite rules. Arithmetic progression is also a sequence, but if and only if, this is the special rules of arithmetic progression. What kind of a rules is applied here? If and only if the difference of any term from its preceding term is constant. I'll give one example for that. Okay, look at this. Okay, 8 comma 10 comma 12 comma 14 comma 16. First term, what we call it as a, the second term 10, the third term 12, the fourth term 14, fifth term 16. The difference between these two consecutive numbers, the first term, the preceding number, we call it as a preceding number, and the second term, we call it as a succeeding number. The difference between these two, that is 10 minus 8, that is common difference, it is 2. Okay, common difference is 2. Likewise, the difference between any two consecutive numbers in the given set, in this set, see here 8 comma 10 comma 12 comma 14 comma 16, you can take any two consecutive numbers in this set. For example, 14 comma 16, what is the common difference? 16 minus 14, again 2. 14 minus 12, again 2. 12 minus 10, again 2. That means the common difference, it is a fixed number. This fixed number is added to the preceding term, we will get the succeeding term. It means that add the common difference to the previous number, we will get the next number. For example, accept first number, add the 2 to the common difference to the first term, 8 plus 2, 10. Again add the common difference 2 to the second term, 14. Likewise, okay, there will be a formula to find the nth term. How to write the general formula to find the nth term, the last term? We didn't see in this set the last term because etc. is there. We cannot see here the last term. Then to find the last term, there will be a formula is there. Okay, before we are going to see the formula, first we have to know that the first term is called as a1, that is 8. 10, the second term is called as A2, the third term is called as A3, the fourth term is called as A4, the sixth term is called as A5, is the fifth term is called as A5. So likewise, up to the last term, we don't know that is A suffix an. Okay, an. N means what? The position of the terms. We call it as these number of set, we call it as each number, we call it as a term. That is 8 is the first term, 10 is the second term, 12 is the third term, 14 is the fourth term, 16 is the fifth term. The first term is A1, the second term is A2. We denoted these terms using A1, A2, A3, A4, A5 up to A suffix n, an. How to solve the last term formula? Look at this. The first term, as we know that A1. A1 is A1 is same as A. Okay, the first term is always taken as A. Okay, even though it is A1, we are considering the first term is A. The second term A2. How did we get the second term? Second term, add the common difference to the first term. See here, A2 is equal to 10. How did we get 10? 8 plus 2. What we call it as 2? Common difference. Add the common difference to the first term. We will get 8 plus 2. Okay. So this can be written in a formula like this. Look here. 8 means what? The first term. That is A. A1 or A. A. We can take it as A plus. What is 2? Common difference. It is denoted by D. The common difference is denoted by D. That is A plus D. It can be rearranged A plus 2 minus 1 into D. What is 2 minus 1 into D? 2 means what? The position of the term. See here, A2. A2 means A suffix 2. 2 means the second term. Okay, that is 2 minus 1. 2 minus 1 means 1D. That is A plus D. The third term. Let us take the third term, that is 12. How did you get the 12? 8 plus. Add the common difference to the second term. That is second term is what? 8 plus 2. 8 plus 2 plus 2. A, it can be written A plus 2D. How many 2's are there? 2D is equal to, how to alter this? A plus 3 minus 1. How did we get 3? So 3 minus 1 is what? 3 minus 1 is 2. A plus 2D. Again, the fourth term. What is the fourth term? 14. How did you get 14? Add plus 2 to the third term. What is the third term? 8 plus 2 plus 2 plus. Okay, take that 8 plus 2 plus 2 plus 2. That is A plus 3D. Okay, A plus, the 4 means the fourth position, 4 minus 1 into D. That is, again we will get A plus 3D. Likewise, the last term an, look at the formula. Finally we got A plus, okay, n minus 1 into D. N minus, the last term is suffix n, that is n minus 1 into D. What is the last term? an is equal to A plus n minus 1 into D. This is the formula to find out the last term. Okay, so an means the last term, n means the position of the term, is equal to A means the first term plus n means the position of the term minus 1 into D. Okay, D means the common difference. This is the formula to find out the last term. Okay, so next I will give one example to understand the arithmetic progression. Word problem. Can you see this picture? One boy in front of the shop, he purchased one chocolate for 20 rupees. Next day, he will purchase two chocolates. How many rupees? What is the total cost? One, each chocolate is 20 rupees. The next day, he purchased three chocolates. What is the total cost? 60. Can we write these numbers in an order? 20 comma 40 comma 60. Okay. What pattern in this? Can anyone tell me? Yes, each value has a difference of 20. That is the common difference between any two consecutive numbers is 20. 40 minus 20 is 20. 60 minus 40 is 20. Okay. The next number. How did we get the next number? Add the constant number to the previous number, that is preceding term. We will get the succeeding term. Can we write the next three terms? Yes, we can write it by adding the common difference to the previous number. What is the previous number? 60. 60 plus 20, 80. 80 plus 20, 100. 100 plus 20, 120. We can write it so on. This is arithmetic progression. Hope there will be another definition is there. What is an arithmetic progression? I will show you. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay. Arithmetic progression is a list of numbers. List of numbers means it is also a sequence. Okay, in which each term is obtained by adding a fixed number. What do you mean by fixed number? It is a common difference. By adding a common difference to the preceding term except the first term. Okay, adding a common difference to the preceding term, we will get the succeeding term. That is called as a arithmetic progression. This fixed number is called as a common difference. Or 0. Okay, D, the common difference is denoted by D. It may be negative or positive or 0. I will show an example for that. Take this. 5 comma 10 comma 15 comma 20 25. What is the common difference? 10 minus 5 5, 15 minus 10 5. Yes, it is an arithmetic progression. What is the first term? 5. A is equal to 5. What is the common difference? D is equal to 5. Okay, what is the last term? If there is any last term, is there? No, it is an infinite arithmetic progression is also. Okay, take the second example. 130 comma 128 comma 126 comma 124. What is the common difference? 128 minus 130. Okay, that is minus 2. What is the common difference? Minus 2. The common difference, I am already told you, common difference may be negative, positive or 0. Now in this example, the common difference is minus 2. 126 minus 128. Minus 2. Yes, it is also an arithmetic progression. The next one, 7 minus 11, sorry, 7 comma 11 comma 15 comma 19 comma 23, etc. What is the common difference between these two consecutive numbers? 11 minus 7, 4. The common difference between these two consecutive numbers is 0. 8 minus 8 is 0. So I hope you will understand what is an arithmetic progression, what is the formula to find out the nth term. That is, can you see this here? The term of an AP are written as A1 comma A2 comma A3 comma A4 comma A5. These are the term. The first term A1, second term A2, A3, A4, A5, etc. That is compare this first example to this one. A1 means 5, A2 means 10, A3 means 15. The first term, the second note, second one, the first term A1 is generally written as, I'm already told you, A1 is generally written as A. Okay, the nth term of an AP is written as A suffix n. Then the formula is to find the last term an is equal to a plus n minus 1 into d. Okay, I think this comes to an end, this session. I think all of you understand the arithmetic progression. I think all of you enjoy this session. I will continue in the next class. Bye.